Student Evaluations of Teaching, or SETs. They've been distributed, processed, and summarized for 100 years, but loved by almost no one. Students dread them as another thing to do on already full plates and often question their value. Teachers fear them as what students can say can have a disproportionate effect on their morale and careers. And despite the clean, quantitative numbers they bring to the table, administrators suspect that deep down they may be an unfair way to judge the many Herculean efforts of teaching that go on at the university. But in spite of it all, the United States and many other countries around the world continue to use the Student Evaluation of Teaching, or SET, as the primary or sole means to judge teaching. Which begs the question, what do SETs really tell us? Are they really reflecting how good a teacher is, or are they measuring something else entirely? That is the question posed by today's presentation. Let's take a look at the research behind SETs and possible answers to this question. To begin, let's take a brief look at the history of student teaching evaluations. The first SET was developed and administered at the University of Washington in the 1920s. At the time, the SET was designed to be a formative instrument, one that would illuminate the opinions and perspectives of the student in such a way as to provide constructive advice for improving teaching. Students would write and rate, teachers would read and improve. Nowhere did the founding fathers and mothers of the SET anticipate that these instruments would ultimately play a critical role in deciding many a career in the academy. By the 1960s, most higher education institutions in the U.S. had adopted SETs, and many had decided that the numbers they generated were well suited for making summative assessments, to decide the goodness or badness of teaching through what students thought and wrote on a form at the end of a semester. By the 1970s, a large majority of institutions had decided that using SET numbers to judge teaching was a grand plan, and the SET continued to gain popularity and power that far outweighed its origins as a helpful tool to improve teaching. Research on SETs grew almost as rapidly as the use of SETs, and by 2009, France had had enough and decided that SETs could not be used to make or break any career. France mandated that SETs could only be used as formative instruments, as was their original intent. Meanwhile, in the U.S., the bludgeoning of academic careers with SETs continued. But in 2014, Stark and Freishtat from UC Berkeley published a comprehensive assessment of how SET ratings were used in the numbers game, and released a flurry of public comment, blogging, and other pent-up frustration with the history of SETs. Not unexpectedly, the backlash against SETs led to some legal action and negative promotion and tenure decisions. And in 2018, formal arbitration in Ontario, Canada, ruled that Ryerson University could no longer use SETs to measure teaching effectiveness in promotion, tenure, and merit decisions. Why all the commotion? Are SETs really that bad in measuring teaching quality, or are they just misunderstood? Taking a look at research on SETs can provide valuable insight into these questions. Rather than reviewing the hundreds of articles in the peer-reviewed research published on this topic, we will instead look at published work that reviews large numbers of these articles in a single swipe of publication in order to get at the big picture much more quickly. The first article on our plate today is a meta-analysis by Uttl and co-authors, published recently in 2017 in the journal Studies in Educational Evaluation. A meta-analysis is a neutral analysis of several scientific studies to identify a common truth among them. In this particular meta-analysis, Uttl and co-authors analyzed 7 studies conducted between 1981 and 2009 that were similar by virtue of their use of the multi-section approach to studying SATs. A multi-section approach studies courses made up of multiple sections with different instructors. The content, homeworks, exams, and other aspects of the sections are as close to the same as possible. Only the instructor and students in individual sections are different. This multi-section approach allows the relationships between SAT ratings and student learning to be studied with minimal interference from confounding or irrelevant factors to the study itself. When the authors of the 2017 study investigated 51 multi-section studies published in 7 different meta-analyses, they overturned the original conclusions by several of the original authors that student learning was indeed correlated to or associated with SAT ratings. The authors in the 2017 meta-analysis showed that the original conclusions emerge as a result of statistical anomalies associated with the small numbers of students in various sections, a problem that's called small sample size bias. Publication bias was also determined to be a factor in several of the previous studies. Publication bias happens when the outcome of a study influences whether or not to publish it, and can be a function of current trends, or can be a result of a long-standing bias against publishing negative or the absence of results. The bottom line from the meta-analysis of meta-analyses done by Uttl was that there is no conclusive evidence that SATs measure student learning, despite the large number of multi-section studies undertaken to find such a connection. Although, in theory, it's possible that Uttl's analysis failed to find a relationship that actually exists, given the large number of studies assessed, evaluated, analyzed, and reanalyzed. This is certainly unlikely. In another major effort to understand what SATs do and don't offer, Spooren and co-authors also undertook an analysis of a large number of articles on SATs. But unlike Uttl and co-authors who chose to conduct a meta-analysis, Spooren and co-authors conducted a literature review of SAT studies, covering 160 articles published since the year 2000. The goal of the literature review was to use these many studies to determine how valid SATs are as a measure of teaching quality. Validity refers to how well an instrument like an SAT measures what it professes to measure. Of particular interest to understanding whether or not SATs are a good measurement are construct and outcome validity. Construct validity is a measure of how well SATs measure what they are supposed to measure. In other words, do SATs really measure and evaluate the quality of teaching? Good construct validity will allow us to say that SATs indeed are a good measure of teaching quality. Also of interest to our understanding of SATs as useful tools for college teachers is the concept of outcome validity. Outcome validity refers to whether or not the outcome of the SAT and its use is valid. Are these SATs used in appropriate ways in higher education? Let's take a look at these two forms of validity to get a more statistically astute understanding of the value and use of SATs. Construct validity, which ensures we are measuring what we think we are measuring, requires that SATs have both convergent and discriminant validity. What is convergent validity besides a lot of syllables? Well, it indicates how well the measure of an instrument, the SAT, is related to other measures that we expect it to be related to. An SAT with high convergent validity, for example, would imply that SAT scores are significantly and positively linked or correlated to objective measures of learning, assuming, of course, that the objective of college is for students to learn. And among the many studies on SATs, we find mixed results to questions of convergent validity. For example, multi-section studies have demonstrated positive and moderate links or correlations between SAT ratings and grades. But the more recent Uttl study that we just discussed on previous slides refutes these results. The bottom line, convergent validity with respect to grades is ambiguous and not certain at all. SET ratings are positively and significantly linked to subjective measures of student learning. What students think they've learned is definitely linked to their SET ratings of a professor. Are they? Yes, they are. Multiple studies show strong correlation between students' perceptions of learning and SET ratings. While this is promising in terms of convergent validity, the lack of consistent connections between objective measures of student learning, like grades, and SET ratings leaves questions regarding the overall convergent validity of the SET. While convergent validity evaluates how well things that should be related are related, discriminant validity evaluates how well things that shouldn't be related aren't related. Discriminant validity is kind of the opposite of convergent validity, but both are needed to support construct validity and to say that SETs actually do measure teaching quality. For example, if an SET is measuring teaching quality and women and men with the same teaching quality get different ratings, then discriminant validity is poor. SET ratings were never designed to measure gender, and this bias gets in the way of what is truly being measured, the quality of teaching. In another example, studies reviewed by Spooren also show that class size affects SET ratings. Larger classes tend to get lower SET ratings than smaller classes, even when the teaching quality is the same. So, SET ratings are biased against large classes, which threatens their discriminant validity and therefore their construct validity. Moving on now to outcome validity, Spooren and co-authors evaluated outcome validity among the 160 articles they studied in writing their literature review. Are SETs used appropriately? We can evaluate this question from 3 different perspectives: from students, from teachers, and from administrators. Let's start with the students themselves. Are the students taking the SETs seriously? Do they see the results of SETs on teaching via changes in the way teachers teach, the way they receive awards, and other happenings in their campus experience? Do they use SET ratings of their future professors to select courses? The answers to these questions are not, by any stretch, a resounding yes. In fact, among the articles reviewed by Spooren, students were generally ambivalent about the value of SETs and did not rely on them to choose their courses and professors. So, from the student's perspective, outcome validity gets a thumbs down. What about from the teacher or professor's perspective? Do teachers use SETs to improve their teaching? If they did, this would represent some hope for outcome validity. Well, teachers were about as ambivalent as students with regard to SETs. While they generally thought SETs were important, they thought the ratings and feedback that students gave only had limited value for improving teaching. What students said were reviewed as hints about how to improve a course, but in general, teachers didn't think that SETs were a great or valid measure of teaching quality either. Well, and how about administrators, our last hope for outcome validity? Administrators do see SETs as great measures of teaching quality, offering quick and simple indicators of performance in the classroom. While administrators use these numbers because they are often the best that they've got to measure teaching quality, the way SET numbers are averaged and otherwise aggregated often violates multiple statistical rules regarding how ordinal variables obtained from a Likert scale, such as that on SETs, can be used. So what's the bottom line? Well, SETs have at best mixed construct validity, meaning that they do not necessarily measure what they are intended to measure: teaching quality. They seem to do a good job of measuring students' perception of what they learned, which in some fashion is influenced by teaching quality. Even so, mixed construct validity brings into question whether SETs have good outcome validity. Are they being used appropriately? And like construct validity, the outcome validity of SET ratings is highly muddled and uncertain, often ambiguous, leaving the rational student or administrator ambivalent about their use. Overall, SETs give us, at best, a mixed measure of teaching quality, and at worst, an erroneous such measure. To round out our investigation of SETs today, we'll now take a look at one more type of analysis of the scientific research on that topic, one published in 2014 from UC Berkeley as an evaluation article, intended to look at the SET research from a specific lens. The authors chose the lens of statistics to see if SET numbers were used in mathematically acceptable ways that would justify the conclusions made from these numbers. Well, for starters, let's take a look at the idea of taking an average of multiple responses on an SET. As briefly mentioned in our discussion of outcome validity, SET scores produce what are called ordinal and also categorical values. This means that a score of 5 representing something like excellent is definitely better than a 4 representing something like very good. Likewise, a score of 4 is better than 3, 3 better than 2, and so on. But even though the scale is monotonic and increasing, meaning the higher the score the better, that certainly doesn't mean that the difference between a 5 and a 4 is the same as the difference between a 4 and a 3. And it also doesn't mean that one student's 3 means the same as another student's 3. So when we take the mean of all these scores, we don't get an average score. We get a number that represents a muddled mess of variations among our students and among interpretations of the words to which the scores were attached. This is the type of stuff that can give statistics professors nightmares. The authors of the UC Berkeley study went on even further beyond the averages in evaluating SETs and common interpretations and misuse of scores. It is a very rare occurrence indeed when all of the students in a class complete the SETs for the course. And when the SETs are online rather than on paper, responses dwindle dismally below the 50% mark. This, of course, raises big questions about whether the students who didn't respond are pretty much the same as the ones who did respond, making it irrelevant what the response rate is. Unfortunately, all students are not the same. In fact, the ones that tend to jump on completing their SETs, particularly online, tend to be those who are less satisfied with the course, leading to SET ratings that are oddly correlated to response rates, rather than teaching quality. The bottom line on the use of standard descriptive statistics like averages, mean, modes, standard deviations, and the like on SET scores is danger, danger. SET statistics can become career biohazards. And as unfortunately, low response rates may be blamed on the instructor, but whether they are or not, they undoubtedly threaten the integrity and accuracy of SET ratings. In the end, what we see from meta-analyses, literature reviews, and evaluations of many and varied studies of SETs is that while SETs were designed to measure how good a teacher is, they unfortunately usually measure something else entirely. But what is that something else? Looking at a wide range of research on SETs conducted over the past 4 decades, the bottom line is that SETs most accurately measure how satisfied a student is with a particular course, which happens to be strongly linked to the grade the student anticipates getting in the course. So while SETs have value in measuring student satisfaction, which does in fact often lead to good academic outcomes like graduating and learning. The bottom line is that evidence that SETs measure teaching quality or learning within a particular course is ultimately lacking. In many ways, it's a confusing and muddled mess. The numbers that emerge from course SETs. Used wisely, SETs can be held up as an indication of how student satisfaction fluctuates for a single instructor over multiple courses. Used wisely, SETs should be combined with other measures, such as peer observations of teaching and outside faculty developer assessments, to make conclusions about actual teaching quality.